Alright, so now we moved on to problem 64 from chapter 4. This one is a sluice gate that actually can have a bit of a confusing flow. You know, you've got some of it going out, some of it trying to go back in. A lot of craziness going on. This particular example is a good example of a control surface. And what that, means for our calculations. Alright, so determine the net flow rate of water across the portion of the control surface at section 2 if the channel is 20 feet wide. I believe, section 1 is over here above the sluice gate. Section 2 is down here where the velocities are indicated. Alright, so it is asking us for Q. Alright, Q is, generally speaking, velocity times A. Now, we've got some Q going in, and we've got some Q going out. And we're really interested in the net Q. Alright, so Q net, you can do this pretty intuitively. Just look at the picture. Flow out is, generally speaking, positive because, it's coming in from this side. We want it to go out this side. So, Q out minus Q, that's too many lines there, minus Q in. Alright, Q out being, is going to be the velocity times the area. I forgot to indicate that this is, how wide is this? It says 20 feet, but it does not appear anywhere in the problem. Yes, it is. The channel is 20 feet wide, so I will indicate depth here. The depth of the sluice gate and the depth of the channel is 20 feet. Alright, so that is the velocity going out is 10 feet per second. Last time I wasn't really paying attention to units because we were already really focused on how we were deriving everything, and since you were doing derivations, units can get kind of confusing and really detract from what you're trying to do, but in this one we want to make sure we still wind up with the right units. So we've got feet per second times the height that is accruing this velocity, that is using this velocity, is 1.2 feet. That's the area that velocity covers, times the depth of the dam is 20 feet. Minus, we have 3 feet per second, which is occurring over the top 1.8 feet. Should be a decimal there. Times 20 feet. Alright, these both come out to be in feet cubed per second. That is correct. That is exactly what we want. That is flow rate. It's the volume that goes out per second. And I'm not sure if I'm reading this right. Yes, I am. That's going to be 132 feet cubed per second. That is the net flow rate. Oh, my poor camera has been on this entire time. Okay. And that is that. This, again, this is an example of control surface, more so, not material derivative, really. More like, what are we focusing on?